Muse Glimmer is a 30 billion parameter agentic model from Meta. And today, its weights are free for anyone to download. Not for a data center, for one consumer GPU, the kind inside a gaming PC, or a MacBook. Meta says it outperforms every model in its size class on agentic tool use. And it says so with published tables. So what exactly is Muse Glimmer? How does 30 billion parameters fit in 24 gigabytes? And what survived the squeeze? Muse Glimmer comes from Meta Superintelligence Labs. It is one dense transformer built for a single job, always-on agent work running locally. The license is Apache 2. Full precision weights and pre-quantized GGUF builds are on Hugging Face right now. Meta positions it for 4 jobs: local agents, function calling, local coding, and judging the outputs of other models. A dedicated perception encoder lets it read images. Screenshots, charts, and documents sit interleaved with the conversation, so an agent can see its own screen. Its context window holds 131,072 tokens, enough room for tool output, instructions, and a long chain of observations. The normal agent stack assumes the cloud. Every step is an API call. Latency, token bills, and your data leave the machine. Glimmer inverts that. The model lives beside your files. It works offline, costs nothing per token, and personal context never has to leave. And it is trained for agent behavior specifically. Precise tool calls, plans that survive many steps, and recovery when a call fails. It also exposes controllable reasoning effort. You choose the balance between answer quality and response speed per task. Glimmer was not trained from scratch. It was distilled from Muse Spark, Meta's much larger, closed-weight teacher using logit distillation. Then came mid-training, longer contexts, agent-heavy data, and richer reasoning traces mixed with organic data. Finally, post-training, supervised fine-tuning, on-policy distillation, and reinforcement learning across reasoning, coding, and agentic tasks. The goal of that recipe is specific. Transfer a frontier teacher's agentic reasoning into a model small enough to live on your desk. Here is the wall. At full precision, 30 billion parameters need over 55 gigabytes of memory. No consumer card has that. So Meta ships Kquant builds at roughly 4-bit precision. The language model shrinks to under 20 gigabytes. The 17 gigabyte build targets a 24 gigabyte card. That envelope must also hold the KV cache, the perception encoder, and the drafter. The second wall is speed. A language model normally emits 1 token at a time. Long agent loops make that painfully serial. So Glimmer ships a small companion model called DFlash. It proposes whole blocks of tokens. The big model verifies them in parallel. Accepted tokens are identical to normal decoding. Meta measures up to 233 tokens per second on an RTX 5090. That is 3.1 times faster. On Meta's published table, Glimmer leads its class on agentic tool use. On MCP Atlas, it scores 75.5 against 54 and 62. But it is not a sweep. Qwen 3.6 leads on OS World, Terminal Bench, and GDP Val. These are vendor-reported numbers on Meta's chosen harnesses. The runtime ecosystem moved fast. llama.cpp and transformers worked on day 0. Llama LM Studio and Unsloth followed the same day. On an Apple Silicon Mac, it is one command: llama run Muse Glimmer. NVIDIA and AMD support in llama is still landing. AMD published its own measurements: up to 53 tokens per second on a Radeon AI Pro and 24 on a Ryzen AI Max laptop chip. Now the constraints. Meta warns that quantized builds can show minor quality differences in edge cases. The 24 gigabyte build averages 1%. Meta's own safety rows favor Gemma. Glimmer violates memory constraints more often, so Meta urges human review before irreversible actions. Its knowledge cutoff is January 2026. It handles text and images only. No audio in and no audio out. And the model is only the brain. Your harness still owns the tools, the permissions, and the final decision to act. The memorable idea is not a benchmark. An open agentic brain distilled from a frontier teacher now fits inside the computer you already own. So test it where it matters. Download the weights, point your harness at it, and judge the whole agent loop on your own work.